We left off on head and neck, and I'll move on to the shoulder region right here. The word for anatomy in shoulder is acromial. And you can put that all under upper limb. We usually say upper limb, upper extremity, but the point of attachment basically is shoulder, acromial. Your armpit region is axillary. Where's that term at? It's over here. The axillary region, hard to see. You can usually see the arm if it's stretched out like that. And the axillary region is underneath. But when your arm is at your side, you kind of have to point to that crack. Axillary. Basically your armpit. In anatomy, the region between, like I said earlier, shoulder and elbow, that's the brachium, or the brachial region. So let me define that. Region between shoulder, elbow. So there's the term there, this region here between shoulder and elbow. And that's confusing because in everyday language, this whole thing is your arm. But in anatomy, it's just that first part. Not to be confused with the antebrachial region, which is your forearm, the region between elbow and wrist, which is the antebrachial region. Antebrachial is your forearm. Think of it as region between elbow, wrist. Now the crook of the elbow on the front, where they draw blood from typically, is called the antecubital region, basically the front of your elbow. Antecubital region, there's usually a superficial vessel there for blood draw. Think of it as the region that is the front of the elbow. That's what it's pointing to. So if you move on down from the brachium to the antebrachial region to the wrist, the word for wrist anatomy is the carpal region. Carpal. Wrist. And you got the hand attached to the wrist. Now the word for hand is the manual region, or manus for hand. In terms of fingers, I want you to know that thumb is pollex in anatomy. Pollex. The thumb. We number the digits 1 to 5, and the thumb is digit number 1. Or digit 1. So thumb is 1. I know this is the number 1 sign, but this is actually digit 2. Okay. So the other digits, let's just call them digits for now. Okay, we'll number them later. The other 4 fingers, just call them digits. Digits, fingers. All right, let's move away. We did the upper extremity. Let me make sure I covered all the terms there. We'll do the back side later. Maybe we should do the back side now, so I'm very complete about upper limb. The only thing I didn't do from the posterior view is the back of the elbow, and that's called the olecranon, the bony part of your elbow when you elbow someone. So the olecranal region. So I'll list that as part of the upper limb. Posterior elbow. So the anterior elbow, that's the antecubital region. On the back of your elbow, that's the bony part, that's the olecranal region. Okay, so let's move into looking at the anterior view, the dorsal region. We did the axillary region right there, but all of this here, this big area, it's part of the thorax. So let me put that word up there. Moving away from upper limb to trunk. Under trunk, you could list thoracic region. So it's got that CIC, but it's pronounced thoracic. The first C is an S sound, and the second C is a hard C. That's basically your chest region. But right in the middle, where your breastplate is your sternal region, or your sternum. Sternum. Sometimes known as the breastplate. All right, so then you have this border traces the rib cage there. And so below that, inferior to that, is the abdominal region. And at the very center of the abdominal region is the umbilical region where your navel is. Okay, so that whole region, still under trunk, is the abdominal region. Notice the abdominal region on the very front, it's very tall up and down, but it kind of shrinks on the side because your ribs kind of go down like this. So like on the sides, I can feel the top of my hip bone, and I can feel the bottom of my rib cage right there. And it's only this big on the side. But on the front, I can feel the bottom of my sternum there and my pubic region down there. It's very, it's much taller right in the middle. But anyways, within the abdominal region is your umbilical region where your navel is. Umbilical. It's the navel region. So they point here indiscriminately for pelvic region. Let me move this whiteboard, it's hiding the skeleton. We got skeletons here from when we get the bone, you can study them. But the bony pelvis, it's easy to see what the pelvic region is. I'm holding it in my hands. It's the widest part of your hips, right? When you put your hands on your hips, you know, you're putting it right there. So pelvis is a word in anatomy that means wide bowl. It's the widest part of your hips. Okay. So let me put that down. The pelvic region. So your pelvic region, think of bony pelvis. You see pelvis a lot in anatomy. It means like, quote unquote, wide bowl. Then they point to the area called the inguinal region, just inferior to the pelvic region, right here. That means groin. It's your groin area. Inguinal is groin. Sometimes in men for physical, you're trying out for sports, that's where they check for hernia because that's a common blowout point of the abdominal region. The inguinal region, see what else we got. Okay, well let's get down to the lower extremity, but let's start with the hip for lower limb. So you have upper limb and lower limb. The coxal region, C-O-X-A-L, that means hip anatomy. Like I said, when you put your hands on your hip, that's basically the region. The other parts of the lower extremity include the region between the hip joint and the knee joint, which is your thigh region or femoral region. Femoral is thigh. Thighs? No, the thigh is, it's the region between your hip and your knee, like I said. Region between hip and knee. Joints. So your knee itself, the bony part of your knee, your kneecap, is the patella. It's a bone. So we call this region, the front of your kneecaps, the patellar region. Patellar is kneecap. So in anatomy, the leg is the region between knee and ankle. Go over here. We call that the, hard to say, crural. The crural region is leg. Region between knee and ankle. So it's very important not to confuse anatomy leg, which is just this region, because in everyday language, this whole thing is your leg, right? And that's usually what we say. But in anatomy, it's thigh, then leg. Now, the ankle is known as the tarsal region and the calcaneal region. Those are a couple of bones of the ankle that we'll learn later. So let's put tarsal as the ankle region. It's one of the main bones that forms the ankle region. Well, anyways, the calcaneal region, what they're pointing to is the heel of your foot. Calcaneal region. Heel of the foot. Basically, foot in anatomy is the pedal. So I'll put that, pedal, foot. Okay, so we went all the way down the lower extremity. So let me do the back of the knee, and then we'll go back up to the back. There's some regions here I didn't mention yet. Well, anyways, okay. So right here, back of the knee, popliteal region. Front of the knee, patellar region, your kneecap. Back of the knee, popliteal. Put it here. back of knee. You know, the back of your knee doesn't stick out. It's a little depression. It goes in, and there's a very important artery back there. It's called the popliteal artery. Popliteal artery is in this region. It's very deep. And it's very important that you have a major artery on the back of the knee, not the front of the knee, right? That doesn't make sense. What happens if you skin your knee? You're going to burst a major artery. So it's back there for protection. Okay, so let me, since we're doing back of the knee, why don't we do back of the leg? Your calves, the back of the leg, it's the sural region. Sural. Sural is calf, back of the leg. So sural, crural, front of the leg, back of the leg, and let's do the other posterior things. The back side is the dorsal region. Go back over here. Dorsal, back. So it refers to all of this in blue. And the subregions, like right down the middle, you got your spine. That's known as the vertebral region, where the vertebral column is. And you can palpate the bony processes of the spine, even through your skin. So the vertebral region, the axis of your body, your spine. We'll study the vertebral column later in the course. You have the small of your back, the lower back. On either side of the spine is the lumbar region. Lumbar. Think of it as either lower back, or people call it the small of your back. That region. And just below that, the inferior part, your tailbone is the sacral region. Inferior to the vertebral region. So list sacral. Sacral region, tailbone, basically. The buttocks is your gluteal region. And the area between the thighs and the buttocks is the perineal region for anus and external genitalia. Perineal. Area between thighs and buttocks. Think about the shape of those small bike seats that you sit on. That's the shape of the perineal region. It accommodates that region, basically. It's hard to see where they're pointing at there. Making sure I got them all. Oh, I forgot a couple on the back of the head there. There's a bunch, but the only one I want you to know is the base of your skull on the back, the occipital region. Okay. Occipital. Base of skull posteriorly. lot of anatomy terms. I did a labels on, labels off, so you can kind of just drill and practice and make sure you get those terms down. Those are the most basic things we can present on the first day without even looking at any internal structures. Just the surface features, what are they called? Now, if you want to start cutting the body open, you have to learn the typical planes and sections that are used in anatomy so we can view things deep to the surface. Okay, so let me show you this figure from the book, and they have a picture there of a person in the anatomical position, and there's a plane cutting her in different ways, and those have names. When you cut, you can see internally. You can see the imagery below when they cut. So if you cut a person right in half, and you make left and right halves, or any plane, anywhere off center, but it's called the sagittal plane. Now if you cut right down the middle, that's mid-sagittal. So let me list that on the board. So in the sagittal plane, when you cut in that way, you create left and right pieces. And if you cut right down the middle to make left and right halves, well, that's mid-sagittal. So, sagittal, mid-sagittal. Cut it exactly in half, creating left and right halves. You can kind of see from a sagittal view, the picture below, which you can see. Now, if you cut, creating pieces that are kind of front and back, this middle one, that's called a frontal or coronal plane. Okay, with this view here, you can see the lungs and the heart and the liver and other organs there. All right. Coronal, frontal plane. Create front back pieces. And you can cut in this plane, you can move body parts in these planes, and there's anatomy words for that. For example, let's do this one first. The sagittal plane, you cut right in half. Now, if I move my arms forward and back, my arms like I'm running and do the running man, my arms and legs are moving in the sagittal plane. And we basically call that flexion extension. Okay, like if I stand in the anatomical position, look at me from the side, and I bring my arm forward, that's flexion. If I bring it back, that's extension. The same thing for if I move my hip joint. If I move my whole lower extremity forward and then back, that's flexion and extension. So what we say is flexion extension is movement in the sagittal plane. Let me write that here. Flexion, F-L-E-X-I-O-N, extension. Is movement in the sagittal plane. But I can move my limbs from side to side. Like if I stand in the anatomical position, I move my arms straight out this way, like making snow angels, right? I can move my arms and leg out like this. That's movement in the coronal plane. And we call that abduction, adduction. When I move my arm away, like tragically a child abduction, you take the child away, okay? You bring it away from the midline, that's abduction, abduction as we call it. Abduction. Versus a deduction. And I just capitalize the first two letters for clarity, because when you say it, it sounds the same, abduction, adduction. So move your arms and legs out, that's abduction. Move it back, that's adduction. when you add numbers, you add them together, right? ADD. So when you adduct, you bring it together. That's where that word comes from. Anyways, that's movement in the frontal plane or coronal plane. Movement in the frontal plane. Frontal plane makes a little more sense. They use the word coronal a lot in anatomy. I guess way back when, you know those Roman crowns that are like leaves, you wear it? Like that. So it's like a crown, right? That's the plane. They still use that term. Coronal and frontal, those terms are interchangeable. The other way you could cut a body is just cut it right this way, make top and bottom pieces. So you can see that in that view. That's a transverse plane. Transverse, or sometimes it's called cross section. Transverse plane, sometimes called cross section. Create top bottom pieces. So those are the ways we can cut the body. Here's a slide of the different movements of the body. I didn't define all of these. I just want you to know flexion, extension, abduction, adduction, because it's movement in those planes that I taught. I'll teach you the other movements later. But just to look at the still picture, flexion, extension of the arms and legs are shown here. And there's abduction, adduction, movement at the shoulder. Okay. So any questions on all of those language of anatomy things, all the regions, what anything's called, is anything you missed or something? So I'm going to move on to a different topic. Chapter 1 also does talk about level of organization, structural organization, and this is a useful figure to make sure you know the difference between small and big things in this class, basically. The smallest level of organization, let's call this levels of organization. Are atoms, which form molecules. So it looks like they go with, that looks like a water molecule, I guess. The atoms is the smallest, so we'll start there. They form molecules. Like hydrogen and oxygen form a water molecule, good old H2O. Okay, and that's the discipline of chemistry. Now, in biology, at the cell level, there are subcellular things that we talk about. For example, they list some molecules form organelles of the cell. In their example, they list a mitochondria, so I'll put that in parentheses. We'll talk about all the organelles of the cell in chapter 3 within the first unit. The cell is the basic unit of life. Basic living unit. They have a whole chapter devoted to the cell. They use as an example a smooth muscle cell. It's a spindle-shaped cell, and it has a solitary nuke right in the middle. Okay, so here's an example of a muscle cell. And the reason why we call it the basic unit is these cells represent all the things of life that we talked about. For example, you can take from a whole organism, you can take out smooth muscle cells. I used to do this when I was a grad student. I studied heart disease, and these are some of the muscle cells that line the heart wall. And you can put these cells in a little petri dish and add nutrient broth. I'm not going to test you on this, but what I want you to know is these can live and divide outside the human body. So that's why we say it's the basic unit of life. They can live by themselves, and it helps if they have a bunch with them in the petri dish, because they secrete messages to each other in the little dish outside the body in your little incubator there. And they can live all by themselves. Now in the organism, you go back to this picture, this cell type, they form tissues. Let me go back over here and start again. Getting larger and larger here. So we get the tissues. To define tissues comprised of a cell type. Comprised of one cell type. So, in their example, the smooth muscle cells. So I'll put SMC as abbreviation for smooth muscle cells of a vessel wall. That's kind of where they're going with this. So a blood vessel represents an organ in this level of organization example. An organ is comprised of more than one tissue type. Composed of more than one tissue type. There's 4 basic tissue types that we'll learn about in chapter 4. So when I say tissue, there's only 4 of them. I mean, we'll list them later. Connective, muscle, epithelial, and nervous. But an organ has more than one of those, maybe all of them. In this example, a blood vessel is comprised of more than one tissue. Example, blood vessel. But that organ has to be a part of a functional organ system that work together to accomplish something. And so blood vessels are a part of the cardiovascular system. Okay. So that's the next level of organization. You can see all the blood vessels, the heart, all the arteries and veins, and how they run throughout the whole body. So that's the next level of organization. Organ system. And that's how your book is organized, by organ system. Example. I'll put CVS for short, cardiovascular system. It's comprised of basically heart, blood, and blood vessels. Okay. Heart, blood, and like our example there, blood vessels. Because blood is basically a liquid tissue, and it needs a vessel to carry it. Blood vessels are containers for blood, and the heart will pump it and generate pressure and move blood throughout the body, and you'll learn about that in 431. You have multiple organ systems that form the whole human organism. So I'll just put human. Many organ systems working together. I don't have time to go through an overview of all the organ systems, but you can read about it in your book, and you'll learn about them as you progress through 430, 431. Okay, so this is kind of like an overview of all of them. So just to kind of look at the slide, what they're trying to show you here is the organism has a membrane around it. We call it the skin. Imagine that skin containing all the organ systems. You ingest, digest food, and what is not absorbed is excreted. Those nutrients are absorbed by the cardiovascular system, so there's absorption there. There's exchanges with the respiratory system, gas exchange, you'll learn about that. And what you need to filter out of your blood is done by the kidneys, which accomplish what's called excretion. Get out of your body. So this is kind of an overview of how the organs work together. If you want to study the anatomy of the organs, you should be aware of the body cavities that the organs lie in. So I'll spend some time defining all the spaces for the organs. Body cavities. Okay. You know, let's start with this picture first, and let me teach the dorsal body cavity first, which is the cranial and vertebral cavities. Body cavities. At some point, I'm going to get cadavers out here and you can really appreciate what's going on with these cavities. But to look at a picture, at least it introduces you to the vocabulary. The dorsal body cavity, by it being called dorsal, you know it's more towards the back, posteriorly. Got your brain case, that's the cranium or the cranial cavity. Cranium, brain case. And then the space in your vertebral column for your spinal cord is the vertebral cavity. Vertebral cavity. Spinal cord. Spinal cord is only 18 inches long. There are other things in there. There are protective membranes that cover the brain and the spinal cord called the meninges. I'll put that too. Meninges. That's, you know, there's other things in there besides your brain and spinal cord. We'll cover it later. Anyways, the name of the cavity, cranium, vertebral cavity. And then if you look at the front, there's anteriorly you have the thoracic cavity and some other regions in there. Let's go back to this picture here and look at the thoracic cavity right there. Basically what we say for the thoracic cavity, that's where your heart and lungs are. Remove the rib cage and you can see it. Thoracic. Practice spelling, practice pronouncing. It's not thoracic, right? It's thoracic. But don't spell it S-I-C. Okay. Thoracic. Chest cavity. Heart and lungs. Contains. Heart, lungs. The lungs actually occupy most of the chest cavity. Usually when I remove a rib cage, what I'll do is I'll cut the clavicles, or collarbones, and then I'll like start cutting down the sides. Okay, and sometimes I'll cut right down the sternum just to kind of go like that. And basically all I see is lungs. And I kind of have to dig around to see the heart stuck in between there. Well, anyways, the space between heart and lungs, there's space there for like your windpipe, your esophagus, major blood vessels. That's called the mediastinum, the space between the heart and lungs within the thoracic cavity. I pronounce it the mediastinum. Some people pronounce it mediastinum. I'm not sure if there's a proper pronunciation, but spell it like that. So within the thoracic cavity, note mediastinum. space between heart and lungs. There's not much space, and heart and lungs occupy most of it, but you do need space for, like I said, trachea, that's your windpipe, esophagus, your food pipe, a couple of major blood vessels, aorta, you know, things like that, okay? They're kind of squeezed in that space. I just wanted to list a few things. Now, there's other things listed there. Now, your heart and lungs, they're in these double membranes. And so it's like, let me get this straight. Imagine this anatomically incorrect picture of the heart. Hearts really don't look like that so much, but it's a familiar shape, right? But there's a very intimate membrane that covers the heart. So I'll trace it in blue to represent that membrane that covers the heart. It's a double membrane, so let me kind of put another membrane about it. And it's not really this big a gap between the two layers, but on the board, when they say the pericardial cavity, they're referring to this space from here to here. The space between the two membranes that surround the heart, okay? So, the membrane that covers the heart, if you had a heart in your hands, it would have a very glistening appearance. It's like if you took saran wrap and put it on top of a piece of steak, and you poke through the saran wrap on the steak. It's kind of like that. This layer right here that's right on the heart is called the visceral pericardium. The second thicker membrane, the outer one, is the parietal pericardium. Those are the names of the membranes. But the cavity in between those two is called the pericardial cavity. It's usually slick and fluid filled. So this space I defined here. Pericardial cavity. It's got fluid in it. It's important because it surrounds the heart. I mean, what if you bleed into that cavity space? You could put pressure on the heart and crush it. You know, this thing could get inflamed and infected, so it's something to think about. But anyways, just know the name of the cavity. The pericardial cavity does not contain the heart. It contains fluid. The heart is contained in the thoracic cavity, so don't, you know, let the anatomist trick you. Because there's also the pleural cavity. So let me draw a lung. Basically that's a lung. And it's the same thing. It's got a double membrane around it. So the black organ represents the actual organ of the lung, but the double membrane are the parietal and visceral pleura. That one on the organ, visceral pleura. It's another membrane. The outer one's parietal. So get used to those words, parietal and visceral. You see those a lot in anatomy physiology. So then what's the space in between there? That cavity is the pleural cavity containing fluid. That's important because that cavity, it has a negative pressure in it. It helps keep the lungs stuck to the chest. Okay, if you ever break this seal, you have what's called a collapsed lung. The lung tends to collapse like a balloon, but as long as that seal is there, your lung is stuck to the chest, and when you breathe, your chest expands and your lung expands with it. That helps to draw air into your lungs, so that space is pretty important. So know the pleural cavity, the pericardial cavity. The pleural cavity, does it contain the lungs? No, it contains fluid. The lungs are contained in the thoracic cavity. All right, so I think that's it there. I got all these spaces. Note the diaphragm. Diaphragm is a word that means membrane. In this case, the membrane is a muscle. It's your breathing muscle. But that represents the border, the boundary between thoracic and abdominal cavities. So let's note diaphragm. Okay, anyways, diaphragm. Just black. The word just means membrane. In this case, the diaphragm, it's a flat, dome-shaped muscle. Look how it's shaped. It's a dome. Right? Functionally, it's your main muscle of inspiration, so you can breathe in. Primary breathing muscle. That's its function. When this muscle contracts, it flattens. You ever notice when you take a breath in, your stomach kind of sticks out? Because it's flattening and pushing all your guts out, okay? But that flattening helps increase your thoracic volume so you can draw air into your lungs. And so that's its function. But we're more concerned in the body cavity lecture. It's the border between thoracic abdominal cavities. Borders between thoracic abdominal cavities. We've had pro sections in the lab where the bottom half is cut off and I can see the diaphragm. I can stick my head all the way up inside it. It's a huge dome-shaped space. Below it, this entire space, the whole space, is called the ventral body cavity, but I usually just go with thoracic abdominal. Okay. Notice that the abdominal cavity, which basically contains most of your digestiveness, or I should note that, abdominal cavity. Digestive tract, mostly. Stomach, that's a good one. People know where that is. And on the left, you got the spleen, and on the right, you got the liver. Just remember, liver on the right, spleen on the left. If you ever see that reversed, that's a very rare case, although that does happen. Your stomach, liver, spleen, most of your small, large intestines. You know, there's a lining of the body cavity. It's called the peritoneum. They say, where's that term here? Ventral body cavity. The lining of the body cavity is called the peritoneum. I don't think the term's on here, but I want you to know it. Membrane, lining, body cavity. A lot of membranes lining things. So I gave you what's called the 3 P's of anatomy. This is the third one, the peritoneum. What were the other two? Pleura, pericardium. Okay, so the pericardium, the pleura, the peritoneum, those are the 3 P's of anatomy that we typically teach. Well, anyways, getting back to the cavity space, the abdominal cavity is continuous with the pelvic cavity down here in the pelvis. I'm going to move the whiteboard again and move the skeleton out. So I'm sticking my hand in the pelvic cavity, right? But I said head because when you're born, pretty much, you came right out of there. That's your head when you were born, okay? And if you've had a child, I think you can relate to that. Anyways, that's the pelvic cavity. Okay, right on the board. And nobody remembers your head coming out of there, but it happened to all of us, unless you're a C-section. Pelvic cavity. Usually what you see in there is rectum anus, the end of the digestive tract. You have the urinary bladder. You have some repro organs, just to name a few things. Like the ovaries are in there. Anyways, just know the name of the space, the pelvic cavity. Let me see if I missed anything. Yeah, I think that's it for all the cavity spaces. More surface anatomy. Because these trunk regions have so many organs, a patient will usually present with a problem in one of these regions, and we can simplify the region into 4 quadrants. We call these abdominal pelvic regions. You can do it with a grid like that, 4 square, creating 4 spaces. Abdominal pelvic regions. And they have the organs pictured underneath there so you can see what's basically there. And I'll just go with the abbreviations. RUQ for right upper quadrant, LUQ for left upper quadrant, and then RLQ, LLQ for right lower quadrant, left lower quadrant. And always know that it's the patient's perspective, correct? I mean, as you look at this side, that's on your right, but it's the patient's left. And always remember that, patient's perspective. Look at this right lower quadrant. Oh, okay, you have pain in the right lower quadrant. That's the vermiform appendix. If that gets clogged with fecal matter, it'll strangulate the blood flow, and you want to remove it before it perforates. You don't want fecal matter in the sterile peritoneum. That's appendicitis, right? We've all heard of that one. That's an emergency surgery, right lower quadrant. Another thing, well, I missed that here, so this one, appendicitis. Just one example of why it's good to know them. Ow, it hurts. It hurts here, so you start taking notes. You can also do a tic-tac-toe grid to create 9 regions. Let's do the top 3. Right hypochondriac region, left hypochondriac region, and in the middle, epigastric region. Let's write those words down. Right, left hypochondriac regions. region, singular. Get rid of the S here. And the middle region is epigastric, which means above the stomach. Because it basically is above the stomach. You ever heard of a hypochondriac person? What is that? It's like a person who always thinks they're sick, paranoid about being sick all the time. And this region got named after them because they're always like, oh, it hurts here. They always like touch that region. So that's why the term hypochondriac means that. But what it really means, chondro is cartilage. And this region, this part of the rib cage is cartilage. Oh, Mr. Skeleton again, going to him a lot. That's cartilage, not bone. Chondro is cartilage. That's why it's right and left hypochondriac regions. Okay. All right, these middle three, right, left lumbar regions, and the middle, where your belly button is umbilical region. Right, left lumbar region. Umbilical region in the middle. Bottom three are right and left iliac or inguinal regions. I'm going to go with inguinal. And in the middle is hypogastric, below the stomach, or it's the pubic region as it's sometimes called. So we'll go right and left inguinal regions. Right, left, inguinal region. I'll accept iliac if you were to put it on some kind of test or quiz. And below the stomach, hypogastric region. There's some blank figures you can study. The last topic I'd like to teach today is the steps of homeostasis, which I mentioned earlier as one of the main physiology processes that keeps coming up in A&P. And I guess the steps to understand in the example of body temperature are always ask yourself those 6 things I have listed for homeostatic mechanisms. So let me define the word formally. I don't think I've done that yet. You know, I looked up the word, what lecture means. Lecture means to go on and on and on and on. And then about this point in the lecture, it starts to feel like that, huh? Maybe you signed up for 54 hours of these, so you're 1 hour down. You got like 53 to go. You're doing good. And the first week, sorry to pound you with lecture, but you had a holiday on Monday. So that's kind of why I have to go a little bit longer the first couple of days. That's why I kind of made the first lab do it for homework kind of a thing. And we'll have some actual lab time next week. But don't forget to come to class Friday. Homeostasis. Let me formally define it. Homeostatic processes maintain internal conditions at appropriate and constant levels, even if the external environment changes. So that's kind of my textbook definition there. Let me write that down. Homeostatic processes maintain internal conditions at appropriate and constant levels even if the external environment changes. And the example kind of illustrates what the body does and what's necessary to maintain these appropriate, constant levels. In physiology, they usually just say steady state. You want steady state, you know, in everything. Blood pressure, blood gases. You ever see that term? So if you disrupt homeostasis, if you get out of this steady state, the body has to autocorrect. And so what are all the components of these homeostatic mechanisms? Let's take note on these 6 things here. The first thing I have is, what's the stimulus? What's the disturbance? Stimulus. Paraphrase, what's the homeostatic disturbance? What's the disturbance? In this example, it's either getting too hot or too cold. Let's go with it's too hot. So the imbalance is increased body temp. You used to say average body temperature is 98.6. There are new studies coming out. Maybe you've heard, no, we think it's a little lower now, maybe 97.5. So it's something like that. But if it gets well above normal body temperature, that's the disturbance in this example. Okay, what's acting as the sensor receptor? You have temperature sensitive cells in the skin and brain. So you need something to detect the disturbance, right? So that's step 2, I guess. Sensor, receptor, detects the disturbance. You have free nerve endings in your skin. Your skin is your largest organ. I know you don't think of it as an organ, but it is. I've skinned entire cadavers, and it weighs a lot. Skin is a great organ. So I'll say, as for our example, free nerve endings in skin. We'll learn later is those free nerve endings, not only that they can detect temperature changes, they detect pain. Pain. That's what they detect, those free nerve endings. Okay, anyways, so you've detected it. You've detected it's getting too hot. That afferent pathway are nerves carrying information to the control center. So let me put that word afferent there. You'll see that a lot, afferent pathway. like when you're affected by something, you receive some news and it affects you. Maybe it's good news, maybe it's bad news, but you're affected. Afferent goes into you. It's information moving to the central nervous system. Info to the brain, to put it simply. It's got to get there. All right, so that's the afferent pathway. And then the control center, what's acting as the control center? Well, in this example, it's the brain. You have thermoregulatory centers in the brain. That's your control center. Step 3. Continue on. Step 3, continued. You know, for all these mechanisms, there's got to be a CPU, something that receives the information as an imbalance and can mobilize the correct output. Receives input, mobilize correct output. And in this example, the increase in temperature is detected by the brain. And then you have efferent pathways, nerve signals, information carried away from the brain, away from the brain. So efferent pathways. Afferent, like the effects with the E. What are the effects, you know, of this drug? You list them. Okay. So the efferent pathways info away from the brain. You're affecting something. In this case, you want to bring the body temperature back down, so you stimulate sweat glands to put moisture on skin. The skin, it evaporates with the ambient air, and it helps cool the body down. So that's number efferent pathway. Then I'll put that for number 4. How about we put number 4 as efferent pathway, because that's the command. And then what's acting as the effector? The sweat glands. What's affected? Sweat glands produce sweat. I'll just say increased sweating. If someone's really overheated, the best way to treat that is undress to your underwear, put them on a table that's tilted, and then spray mist over them. If you don't have that set up, at least lay them down. Okay, anyway, sweating will cool the body off. And then the response is to bring body temp back down. Number 6. Response. Restore body temp. We call this negative feedback because once you restore the body temperature, you shut off the original stimulus. All right? I mean, you should stop sweating after your workout. Okay? Sweating's turned on, sweating's turned off. Excuse me. And actually, sweating is a sign you're fit. A fit person will sweat sooner within the workout, and they'll sweat more because it's an adaptation to exercise. Anyways, write this down, negative feedback. The output shuts off the original stimulus. Okay. Write that down. Negative feedback. Output shuts off original stimulus. The regulation of blood glucose is a good example, even though we haven't had endocrine yet. But like, for example, I can go through it with you now. I don't want to write everything on the board. I just defined everything. But you should be able to, within this chapter, even for the first test, even though you haven't had the material, because I've defined the concepts over here, you should be able to just follow a graph and figure it out. For example, this one's a little strange because the imbalances, the imbalances are strange. Is you eat pasta, your blood sugar goes up. It's absorbed, and the pancreas can detect that. And the pancreas also acts as the control center to mobilize the correct output, which is insulin. Now, insulin can affect all of these things here. And the goal is to stimulate these tissues to take glucose out of the blood into the organ, either to metabolize the glucose for energy or store it for later. That's glycogen there. And then what that does is it returns the blood glucose back to the normal range. So the effector here would be are these organs, these tissue cells, and this liver, and the responses back to normal range. So I talked over the top one. Let me walk you through the bottom one, because I do expect you to do one of these examples for lab. Okay, I use a different example. I think it's regulation of calcium. So like I said, even though you haven't had the chapter on that hormone yet, you could look at that chapter if you want, but you should easily be able to take a figure and walk yourself through it. So let's do the bottom one together. Step one. Stimulus. Blood sugar can get either too high or blood sugar can get either too low. So that's easy. That's number one. Decrease blood glucose. And let's do 2, 3, 4, 5, 6. I want to stop talking for a couple minutes. I want to give you a couple of minutes right now to do this by yourself. Just see if you can walk yourself through it, and you can talk about it with your neighbor if you like, and I'll check back. Put some thought into it. I will have you do this for lab and maybe for the exam, so I want to make sure you can reason this out. All right, let me check back in. I think, let me give you a hint here. Number 2 and 3 are the same thing. What did you think that was? Pancreas. It acts as detects the change in blood sugar and immobilizes the correct response to secrete a hormone. The number 4, the output command is a hormone called glucagon. Now when you study that, you're going to see its effects here. What does it affect? What is this organ? Liver. So you put that for number 5. The response is, if the imbalance is too low, you always want to do the opposite.
Can you write everything on the board?
Sure. So we're going to go number 2, 3, pancreas. It's acting both as a detector and this CPU to be able to detect and mobilize the correct output, which is a hormone called glucagon. It's a hormone. You'll study that in 431, but for this, it's just as an example. Just know that it's going to raise blood sugar, but it has to affect something to do that. Some of your liver, some of your sugar stores are in your liver, the rest are in your skeletal muscle, but let's just pull liver here and keep it simple. Number 5, the effector, liver. The ultimate result is to increase your blood sugar. Increase blood glucose. Glucose is the circulation form of sugar. So I kind of use those terms interchangeably. When the balance is corrected, you turn off the original stimulus, which is to stop secreting the glucagon. But there are examples in physiology that enhance the original stimulus, and we call that positive feedback. Not too many examples that we talk about in physiology, but bleeding is one of them, the control of bleeding. Okay. So this is negative feedback, this is an example. This is the only example of positive feedback I'll give you in this class, okay, just so we can kind of narrow it down, because there's not too many examples. So let me just redefine this type of feedback. You enhance the original stimulus. In this example, since it's the control of bleeding, you enhance the original stimulus until the bleeding stops. Now let me do this one with you because it's kind of hard to squeeze every example into my 6 easy steps. So let me write this one on the board for you. We'll go 1 to 6 again. So here are disturbances, vessel damage. Blood vessels aren't supposed to leak like this. Okay, so the original stimulus here is damaged vessel, bleeding. Now, what senses it? What's the control center? Those don't fit neatly here. What you have to know is, to have a blood clot, you only want it to happen at the injury site. And everything is localized to that little spot there. And it's hard to know because this is the first day. So for this one, 2 and 3, what detects it and what controls it is the vessel injury site. You want to stop the bleeding, but you only want a blood clot only in that spot, not anywhere else. That would be unwanted. What happens is the platelets, they stick to the little collagen fibers from the broken ends. And what they do is they become activated, they release chemicals. And so that kind of acts as number 4, the output command, platelets. They're activated. What they do is they secrete chemicals to attract more platelets. And that's the positive feedback part. Because if you're going to attract more platelets, those more platelets will also become activated at the injury site. And they'll release more chemicals and attract more platelets. And this will just keep going around and around until all of those platelets form what's called a platelet plug. That's the picture right there. So number 5, I'm going to put more platelets. Enhance original stimulus. This is why this is an example of positive feedback. It's a good one. Number 6, the response is platelet plug, stop bleeding. Bleeding stops. Your book also defines, your book is really good at defining a lot of different things. So far you got to keep track of positive, negative feedback. And also, auto-regulation versus extrinsic regulation. Okay, let me summarize that for you. Okay, I'll just erase the top part here. So we have auto-regulation. And extrinsic regulation. Let me read what I have on the slide. So what we've been studying in these processes, auto-regulation or intrinsic regulation, it's the homeostatic response occurs from within a cell, tissue, organ. Extrinsic regulation are most of the ones that we study. The homeostatic response is initiated from activities from the outside, okay? And that's usually what we talk about. And that's 2 primary systems, endocrine and nervous. When we did the blood sugar, insulin and glucagon are hormones involved in the endocrine system. So in the body temperature one, that's nervous. So what we talked about today, extrinsic, endocrine, hormones are secreted. They're from outside the response you're trying to affect, and they go to the correct body part to mobilize the correct homeostatic response, to correct blood sugar, whatever it is you're talking about. So, hormones. The other one is nervous, involving the brain. We talked about regulating body temp today, because that involved the brain. The brain took care of that. So those are usually what we talk about for extrinsic. Auto-regulation, it all happens within the organ. That's the blood vessel example. There was no nerve impulse. There was no hormone that really accomplished this. It all happened within the blood itself. Blood clots all by itself. If you take blood and just leave it sit on the bench top, it'll intrinsically clot. So that's why the blood vessel injury is a good example of autoregulation. It all happened within the blood, and it clotted exactly where the injury was. No outside thing came into it. That's all I have for you today. We didn't have time for lab. I had to introduce the course. But remember, which lab are you doing? Lab 1. Print it out. Bring it to class on Friday. I'll see you at the same time. And
Finish it at home or just to bring it up?
Oh, you gotta do it. Yeah, it's due Monday. I'm assigning it for homework. Yeah, I'll collect it at the end of class Monday. Lab 1 due. End of class Friday. So what I'll do is I'll try to stop lecture a little short, give you some time, but you could do everything. It's just worksheets. So if you have any questions, we're done a little early. And if you wanted to sign those sheets over there for Andrew's Deacon Tutoring, well, you're free to do that too.